So with oxygen being atomic number 8, oxygen being atomic number 8, you have 8 protons, and you have 8 electrons, and electrons are equal to the protons if the atom is neutral. So in the example that I gave with oxygen having a 2 minus charge, so since oxygen has a 2 minus charge, it's not neutral. It's gonna be 8 plus the 2, which would give you 10 electrons. So with 10 electrons, you want to determine the electronic configuration. The atomic number is where your protons are. Neutrons are equal to the mass number minus the atomic number. Electrons are equal to your protons if it's neutral, and so on and so forth. As far as charges, protons have a +1 charge, electrons have a -1 charge, neutrons have no charge. And the example that I used, your mass number will be your 16 for your oxygen. 16 minus 8 would give you a number of neutrons. 8 would be the number of protons. Electrons would have been equal to 8, but because it has a -2 charge, it's going to be 8 plus 2. So the number of electrons that you have will be 10 electrons. Since you have 10 electrons, you wanted to determine with 10 electrons what your electronic configuration would be. So I draw 1, 2, 3, 4, 5, 6, 7. In between 2 and 3, you have 2, 3, 4, 5, 6, 7. So in between the numbers, I have the next number. And then in between 3 and 4, you have the next number. So 3, 4, 5, 6. And then in between 4 and 5, I have 4. So once again, it's 1 through 7, 2 through 7, 3, 4, 5, 6, 4, and 5. And then I start crossing the numbers off. So because I have 10 electrons, I know it's going to be 1s2, 2s2, and then that's 4 down. So I have 6 remaining. So my next number, 1s2, 2s2, my next number would be 2p6. 6 plus 4 is 10. So I have a total of 10 electrons. So I just have that written down here. 1s2, 2s2, 2p6. The last 2 gives me my valence electrons. So I have 8 valence electrons because I just added the 2 plus 6. So a quick review on how I do this. Basically, it's drawn out, and you just start crossing off the numbers. And the way I cross off the numbers, I cross off 2 single numbers, 2 double numbers, 2 triple numbers, and then the last one is my 4 numbers. So what does that mean? I have 1s2, 1s2, 2s2, 2s2, 2p6, 2p6, 3s2, 3s2, and then just start crossing off the numbers. So the way I cross them off is 1, 2, and then 2 and 3, that's my double, and then 3 and 4, that's my second double, 3, 4, and 5, 4, 5, and 6, 4, 5, 6, 7, and these I just left out. So what that leaves you with is the 1s2, 2s2. Basically, this is your s orbital, that's your p orbital, that's your d orbital, and this is your f orbital. So you have s, p, d, d, f. S is I have 1, 3, 5, 7 to remember it. So I multiply it by 2, and you have 2. So 1, 3, 5, 7 gives you 2, 6, 10, 14. And SPDF. So the maximum that S orbital will have is 2. The maximum that the P orbital will have is 6. The maximum that your D orbital would have is 10. And the maximum that your F orbital will have is 14. So I just go through the max numbers and then determine the number of electrons I have, and then just kind of get to that number. So you have 1s2, that's still your s orbital, 2s2, still your s orbital, and then your p orbital starts, so it's p and then another s. So p and another s. And then the next one is also in the p orbital, so you have your 3p6, which is right here, and then your 4s2, which is right here. And then the next one would be your f orbital, and the maximum that you can have, your d orbital, the maximum you can have is on the d orbital is 10. So you have your 3d10, and then following that is your p. 4p6 is your max. 5s2 would be your max. And then this is your second line. So you have your max 4d10, 5p6, 6x2, and then here's your f orbital. Your max here would be 14. So 4f14, 5d10, 6p6, 7s2, and I just honestly went on and just did the rest of them. I counted these out, so I have 2 plus 2 plus 6, 2 plus 6, and the total I have is 118. So I'll use that oxygen example again, where you have your 1s2, 2s2, 2p6. That gives you 10. 2, 4, 6. So 10 electrons. If you didn't have the -2 charge, let's just say that you just had a regular oxygen without the extra -2 charge, you would have 8 electrons, which is the neutral, where the atomic number is equal to the number of electrons. So you have 8 protons, 8 electrons, and the mass number will be 16, which is correct. So in that case, you would have 1s2, 2s2, 2p4. So 4, 5, 6, 7, 8. A total of 8 electrons. That would be your max. But in this case, example that we used, we had an oxygen with a -2 charge, and you just had to determine number of atomic number 8, mass number 16, number of protons 8, neutrons would be mass number minus atomic number, which would give you 8 neutrons. Remember, neutrons have no charge, and electrons would have been 8 if it was neutral, but because it has a charge, a -2 charge gives you 2 extra electrons, so you have 10. And with 10 electrons, electronic configuration with 10 electrons will be 1s2, 2s2, 2p6, and that's what you write down, determine the valence, and you get 8. So trying to see if there's anything else I can add to this. Valence definition. Valence is the number of electrons in your outer shell. So in the case that we just used, our valence has these two numbers in the outer shell. So you have your 6 plus 2, and they have 8 electrons. With phosphorus, you would have five valence electrons with phosphorus. An isotope is something that has the same number of protons but different number of neutrons. So when you have your mass number minus the atomic number, the atomic number stays the same, but the number of neutrons is different. So it's still carbon with, the same number of protons, but different number of neutrons. It still has the same, 6 electrons, 6 protons, 6 electrons, but in this case where you have C12, you have 6 neutrons. C13 has 7 neutrons. and I'll come back to this. An ion is something that has lost or gained electrons. So an example that we had 2 additional electrons, so it would be a -2 charge because it gained 2 electrons. If it lost 2 charges, it would be +2. An anion is something that has gained electrons. A cation has lost electrons. A radical has no loss or gain. It just has a single unpaired electron. So this would be an example. Instead of having 2 on each side, you have 1 single in the Lewis structure for a bromide radical. So that's why you have just 1 dot. Lewis structure is drawn using valence electrons. So once you determine the valence electrons using the periodic table, and you draw it out and determine the 1s2, 2s2, and so forth. This is a noble gas, so that's why I just summarized it by putting that in. I still did the calculations and came up with this. So I know I have, in the final 2, I have 4s2, 2p5, and these 2 will give me my valence. So my valence electrons would be 7, and I use the valence electrons to draw my Lewis structure. So an example here, the Lewis structure for water. Oxygen has 6 valence electrons. When you do the SP thing, it's 1s2, 2s2, 2p4. So 2 plus 4 gives you 6. So 6 valence electrons. Hydrogen just has 1. It's 1 proton, 1 electron. So 1 valence electron, just 1s1. So you draw the Lewis structure for oxygen. So you put in the 6 electrons. So 1, 2, 3, 4, 5, 6, because it's sharing 1 each. And then hydrogen brings in 1. So you have 1 for hydrogen and 1 for hydrogen. So that's your Lewis structure. That's what it looks like. If you need to determine the formal charges for this example that we just had, the number of valence first is what you find out. So determine the charge for oxygen. Oxygen has 6 valence electrons. Remember how we got that? So you have 6 here, and then how many is it bonding with? So I just count the lines. You can do the half bonding, which would give you the same thing. What I mean by that is you can have 4 electrons, so 2 plus 2 giving you 4. Half of 4 is 2. Or you could just count the lines, so just have 1 and 2. So instead of doing this part, I have 2 in here. And then this, you just count out. So it's 6 minus 2, and then the non-bonding electrons. So non-bonding are these ones, 1, 2, 3, 4. So we would have 6 minus 2 minus 4. 6 minus 2 minus 4 gives you 0. Therefore, the formal charge for oxygen is 0 in this case. And that's it.